I would like to take a look at the unit review related to sequences and series, but you should have tried these problems first. So make sure that you've tried them first before you're looking for help on the video. So the first objective, I can write the terms of a sequence given enclosed or recursive formulas. So write the first 4 terms of each sequence. So I'm plugging in 1, 2, 3, and 4 for n. 3 minus 1 squared, 3 minus 2 squared, 3 minus 3 squared, and 3 minus 4 squared. So 3 minus 1 is 2. 3 minus 4 is negative 1. 3 minus 9 is negative 6. 3 minus 16 would be negative 13. So I'm plugging in 1. So 1, and then negative 1 is going to be squared, so that'd be positive 1. So then my next term is 2, but now I'm going to have negative 1 to the third power, and that would be negative 1. So negative 2, and then it's going to alternate between positive and negative. So this is a recursive function. So I'm just taking 3 times the term that comes before it. So if I start at negative 4, 3 times negative 4 is negative 12, times 3 is negative 36, and negative 36 times 3 is negative 108. All right, number 4, write the given term of the sequence. Find a sub 6. So I can just plug 6 in. So I'm doing 9 factorial. On my calculator, that's under math, probability, choice number 4. Oops, I have to type the 9 first. 9, math, probability, choice number 4. 362880. 362880. Let's see, number 5, I have to find a sub 4. So if I plug in 4, I get 7 over 5 times 4 is 20, 7/20ths. Number 6, finding a sub 8, but I have to find all the terms that come before it. So 9, then 15. So it's a recursive function. Again, I'm just taking the term that comes before it and adding the term that comes before that. So 9 plus 15 gives me 24. 24 plus 15 gives me 39. Plus 24 gives me 63. Plus 39, 102. 1, 2, 3, 4, 5, 6. Plus 63, 165. Plus 102, 267. Term 8. 1, 2, 3, 4, 5, 6, 7, 8. 267. So I can identify whether a sequence is arithmetic or geometric and write its closed form. So this is going down by 8. So this is arithmetic. So a sub n equals 60 minus 8 times n minus 1. Times, this is times 0.75 every time, I think. I'm just checking it. Okay, so this is geometric. You should check each term. So a sub n is 80 times 0.75 to the n minus 1 power. So finite differences, let's see, this is a difference of plus 10, that's 14. 56 minus 38 is 18. 78 minus 56 is 22, and those each have a difference of 4, right? So this is a quadratic because it was the second order finite difference that came out the same. Let's see, down 5, 5, 5. So this is linear because they come out the same at that degree. Let's see, this is plus 7. 35 minus 16 is 19. 72 minus 35 is 37. 133 minus 72 is 61. 224 minus 133 is 91, so it's not linear. Let's see, 19 minus 7, so this is 12. 37 minus 19 is 18. 61 minus 37 is 24. And then 30, and then this looks like 6, 6, 6, 6. So this was the first order, second order, third order, so this would be cubic. Simplifying expressions involving factorials. So 6 factorial, so that's 6 times 5 times 4 times 3 times 2 times 1. So you could either do it on your calculator, so it'd be 6 math and choice 4. So that's 720. And 4 factorial over 6 factorial, the 4's are going to cancel. So it's really over 6, looks like 1/30th, right? Because all the 4, 3, 2, 1, 4, 3, 2, 1 are going to cancel on top and bottom. Let's see, 5 factorial over 3 times 2 times 2 is just 12, right, in the bottom. 5 factorial is 120 divided by 12 is just 10. Arithmetic or geometric sequences to model a given situation. All right, so if I give you a sub 6 is 39 and a sub 10 is 63, I've gone up 4 terms. And what is 63 minus 39? 24. 24 divided by 4 gives me a difference of 6. So I need to go backwards to find the fifth, fourth, third, second, and first. So from 39, I need to subtract off 6 5 times. So I think I would start with 9. A sub n equals 9. And I'm going up by 6 and minus 1 times. I'm just going to plug in a sub 10 and make sure it works. 9 plus 6 times 9 would be 63. Okay. Always nice to plug one in and see if it worked. Geometric this time. So let's see. The second term is 70. Third, fourth, fifth is 8.75. So times something, times something, times something. 70 times r cubed gives me 8.75. So I'm going to take 8.75, divide by 70, and then take the cube root of that number. So the cube root is under the math key, choice number 4. I'm taking a cube root of 8.75 divided by 70. So actually, the ratio is 1/2. Yep, it is. Okay, so the ratio is 1/2. That tells me my starting term must be 140 then, right? 140 times 1/2 to the n minus 1 power. Find S sub 3 without using a calculator. So if I plug in 2 times 1 plus 1, 2 times 2 plus 1, 2 times 3 plus 1, I get 3, 5, and 7. And when I add those together, 8 plus 7 is 15. Find the sum of the first 50 positive integers using the finite arithmetic series. So there's 50 of them, so I have 25 pairs. My first term is 1 and my last term is 50. So I'm really just taking 25 and multiplying by 51. So I could do that without a calculator. 1 times 5, 10 plus. I think it's 1275. Let's check. 25 times 51. I can evaluate arithmetic series with a calculator. So I'm finding the sum from -9 to 39, and I can use a calculator. So I'm going to go to math summation. I'm going from n is 1. Oh, I don't know how many terms there are, so I need to figure out how many terms I have. So this is a sub n equals -9. I'm adding 4 n minus 1 times. So how many times did I add 4? Oops. So I added 4, I think 12 times. So -9 plus 4 times 11. -9 plus 4 times 12. So if I need n to be the 13th, this is the 13th term. So I'm going to do the summation of 1 to 13 of that. Math summation, n goes from 1 to 13 of -9 plus 4 times n minus 1, 195. So number 20, I could just plug into my calculator. Summation, n goes from 1 to 90 of 3 minus 2n, -7920. Find the 46th partial sum of this sequence. So math summation, n goes from 1 to 46, 2 minus 3 times n minus 1 times -3013. Infinite sum, and this is an arithmetic sequence, so this is going to diverge. No sum. I can evaluate geometric series with a calculator. So I'm going from 1 to 8, math summation, x goes from 1 to 8 of 4 times 0.25 raised to the n minus 1. 5.3325. So 33325. The next one, I'm doing the 100th partial sum. So n goes from 1 to 100 of 0.4 raised to the n. Looks like 2/3. It's going to actually converge by the time it gets to the 100th term. Infinite sum, use the formula. First term over 1 minus the ratio. So 80 divided by 0.2, 400. And the next one has a ratio that's bigger than 1, so I cannot do it because it diverges. So I can solve application problems involving arithmetic and geometric series now. How many rows are in the corner section of a stadium that contains 2,040 seats if the first row has 10 and each successive row has an additional 4? How many rows are there? So I need to know the number of rows. The first row has 10, each successive row has 4. So that's my arithmetic summation. I need to guess and check how many rows it has. N goes from 1. I'm going to say if it has, what if it has 50 rows? 10 plus 4 times n minus 1. So that's way too many. All right, what if it only has 20 rows? That's not enough. What if it has 28 rows? Still not enough. What if it has 32 rows? Too many. 30 rows? So it has 30 rows. I'm not sure the better way to do that problem than guess and check. If you invest $60 per month into an account that earns 4% annual interest compounded monthly, how much will you have after 1 year? $60 per month. Sum of 1 to 12 months, 60 per month, 1 plus 4% compounded monthly to the n minus 1. Right, that allows us to plug in, for month 1, we just have $60, and then after that, we start getting interest on our interest. So math summation, n goes from 1 to 12 of $60, 1 plus 0.04 divided by 12 raised to the n minus 1. So at the end of 1 year, I have $733.35. That seems reasonable. I invested myself $720, so I only earned like $13 in interest. How long will it take for there to be $2,000 in the account? So n goes from 1 to how many months? 60, 1 plus 0.04, so it's the same formula. I just have to guess and check the number of months. So I've got to get to $2,000. So how much will I have in the account after 24 months? Because that would be 2 years, not there yet. So how about 3 years? Too much. 30 months, not enough. 32 months. So it must be 32, because I bet 31 is not enough. So it'd be by 32 months, there is $2,022.59. How much should you invest to have $2,000 by the end of the first year? So this one I can do without guessing and checking. I want to go from 1 to 12 of some number, 1 plus 0.04 divided by 12 to the n minus 1. So I'm going to actually do the summation and then just divide my summation to the other side. So I'm allowed to pull out that x. So by pulling out the x, so I'm doing n goes from 1 to 12 of 1 plus 0.04 divided by 12 raised to the n minus 1. So that's just my interest. I'm going to take 2,000 and divide by that number. So I have to invest $163.60, well, really 64 cents. 63 cents won't quite be enough, but I rounded to the nearest penny. All right, every month 8 kilograms of waste is dumped into Cook's Pond. 7% of the chemical dissipates out each month. So I actually want to use 0.93 as my ratio because that's what I have left. How much chemical waste is in the pond after 6 months? So 1 to 6, I have 8 kilograms every month, 0.93 to the n minus 1 power. N goes from 1 to 6, 8 times 0.93 to the n minus 1. I have 40.3 kilograms in the pond at the end of 6 months. If the process were allowed to continue indefinitely, what's the maximum chemical waste? So I would take 8 and divide by the 1 minus 0.93. So it's an infinite sum. Oh, that doesn't make sense. Oh, it's 0.07. 8 divided by 0.07. 114.3 kilograms. The state limit is only 75 kilograms. Uh-oh. What is the maximum amount of waste that could be legally dumped? So this time, I want to do an infinite sum, right? So I want to know what starting value over that 1 minus 0.93 will get to only 75. So this is 0.07. So I can actually take 0.07 and multiply it to the other side to get my answer. So 5.25 kilograms each month is the max that I could do. Nat sprained his ankle. Uh-oh, Nat. He needs to take medicine for the pain. He'll be taking 300 milligrams every 6 hours. After 6 hours, 82% of the medication dissipates. What's the maximum amount of aspirin that he'll have in his bloodstream if he continues taking the same dose indefinitely? So he's taking 300 and then 82% is dissipating. So he only has 0.18 left. So 1 minus 0.18. So 300 divided by 1 minus 0.18 is 365.9 milligrams. The doctor decides Nat needs more pain medication. He wants to have the amount of medication plateau around 400. What should the doctor increase the dosage amount to? Well, can we do x over 1 minus 0.18 gets me 400? So I'm going to really take 400 and multiply by 0.82. So if I take about 320, wait a second, we wanted to plateau, yeah, 328. Let's just see. So if I did 328 divided by 1 minus 0.18, that'll plateau at 400 exactly, right? Right, I'm taking more than the 300, so it'll plateau at 400. Okay. After a few weeks, he needs less medication. What if it plateaus around 200? So x 1 minus 0.18. Now I want to plateau around 200. Only 164 milligram dosage. All right. Big questions about sequences and series. Compare and contrast them. Just sequences are ordered lists of terms, and series add the terms of a sequence. What type of function are arithmetic sequences most like? They're most like linear functions. What type of function is geometric most like? They're like exponential, which we've studied this year, right? Linear has a common difference, which is your rate of change, whereas exponential has a common ratio, which is the base of your exponential function. How are sequences different from functions? So sequences, their domain is the positive integers, while functions can have negative or decimal values. And then it says, give a real world problem better modeled by a function. How about sales tax? Right? You can plug any amount in and calculate the sales tax. So $4.80 or $8.90, you can calculate sales tax. It's a linear function. Whereas a better modeled by a sequence, how about paying rent? Right? Paying rent each month, right? There's no halfway rent usually. How are closed and recursive formulas different? Closed, you can plug in any value to generate that term, but recursive, you need all the preceding terms. And it'd be more beneficial to have a closed formula if you want to find a high term, like the 100th term. Yikes, I don't think I want to do that recursively. I hope this has been helpful. Oops. Helpful, though fast. Oops. Bye.